Hello, welcome, John.
Thank you. All right. Ding dong. It's 2026, bro. Coding is largely a solved problem, and TDD is dead. And it's about time, too. I remember back in 2015, DHH tried to warn us of the design damage that it was doing to his Rails code. But of course, Fowler, Martin, and Beck swooped in to shout down any point he might have been making. But I mean, like, who ever heard of testing a thing that doesn't exist yet? And we're gonna trust the same people who write the code to test it? Come on, real scientific, real objective. So much for quality code. It's a complete insult to the whole profession of software testing. That's like a whole job. And I don't know about you, but I don't know what my code is gonna look like. I need to get in the zone. I need to type it this way. I need to type it that way. I need to feel my way through it without a bunch of red tests showing up, making me feel bad and breaking my flow. Speaking of making me feel bad about it, how about the gaslighting that these clowns put us through? Telling us we're not professional if we don't do TDD, if we don't write code in their silly, awkward, backward way. It's slow. It's so slow. I got carpal tunnel from all the typing. It's like 5 times the amount of code just to test the 10 lines that we need to get out to production. It's complete waste. But on the other hand, the lines of code did count toward my productivity quota. So, at least that worked out for me personally. But, it's not testing the real code. The pipeline is green, and we still have a bug backlog the size of Nebraska and growing. It's not worth it because we just end up testing somebody else's code. That's somebody else's job. We're doing somebody else's job. Who's doing our job? Nobody wants to work anymore. Scene. So not all of those complaints about testing with TDD are valid. But from a certain point of view, some of them are. And I am here to declare TDD dead, but not for the reason you might think. And when you've been doing this as long as I have, you notice that the industry starts having the same old arguments with each generation of new engineers that comes in. Before I go into that, who am I? Who am I who have been in this industry this long? I've been a software professional for over 20 years. I've worn lots of shoes. Most of them involve writing code. I've had titles like Agile Coach, Software Architect, Subject Matter Expert for Developer Experience and Productivity, and my favorite one was Nerd Coach. But if I was going to explain to a nice 5-year-old person what I do in plain language, I help people make software cheaper and safer to change. But that's enough about me. I want to learn a little bit about you. First, who knows what TDD is? Okay, good. That's first hurdle. Who uses TDD in their job? Okay, keep your hand up if you like using TDD. Keep your hand up if you are trying to help others around you use TDD. Keep your hand up if that's easy. No, okay. And who here, this is okay too, it's a safe space. Who here is not that into TDD? Doesn't like it, okay. Thank you. Like I said, when you've been doing this as long as I have, you see a lot of arguments rehashed with each new batch of folks that comes in. For example, back when I was just a pup of a programmer, this is how you knew professional software was made, right? This is just what the good engineers do, what the good project managers had us do. You start at the top with, you gather the requirements, and then you hand those off for analysis, and you document your analysis thoroughly and have it signed off upon, and then that hands off to an architect and a team of superior nerds who live in a tower somewhere, and they create the right program design. They make decisions, that gets thoroughly documented and signed off upon. And of course, then you hand it off to the coders, and everybody else goes out to do something else while we wait for 2 years. And then the Agile people came along. And when I said Agile, who reflexively thought something about 2 weeks? Okay, that's what that word means now. Which is relevant to what I'm trying to say. The Agile people said, no, we should start here. We should start with the doing and then, like build it in, maybe do this, but in tighter cycles of doing and inspecting and adapting. And then the TDD people, who are a very special episode of Agile people, they came along and said, start here. Let's start here. We're going to do it backwards, okay? And that's ancient history now. It's all lost to the sands of time and in some books. Please read the books. But what about the modern discourse? So now we have vibe coding, which is like, forget all this, start on the moon. Because you only live once. And spec-driven development, which is, start here. Okay. Why is this so hard? Why is this so hard? We can't answer such a basic thing as where in the process of developing software that we need to even begin. How have we not figured this out yet? And there's been a lot of writing and thinking and discussing of this very problem for generations of engineers. I think Woody Zuill put it in the most concise, useful way when he said, it is in the doing of the work that we discover the work that we need to do. It's in the doing of the work that we discover the work that we need to do. Put another way, we might be wrong. Our plans, however carefully considered, might be wrong, and it's not our fault. It is the inherent complexity of engineering. We cannot know the value of our work until it's done and in use. Cannot. Not that we don't know the value. We cannot know it until it's in somebody's hands. And those Agile people I was talking about earlier, it's not about 2 weeks. This is what they were trying to say the whole time. However poorly that idea spread. But words are hard. TDD was the YOLO option of its day, right? We worked so hard up here in analysis to nail down all the problems and sign off on everything and make it hold still. But where do we always find the problems? In testing. Let's start there. Let's just start where the problems come from. None of this is working anyway. Let's do the whole tree backwards. But it wasn't as reckless as maybe it seemed at the time. They were just rejecting the premise that any analysis could eliminate uncertainty, and the feedback loop was the method. TDD was a strong idea. It's a great idea. And it had a branding crisis. Some of us got it. Some of us get it. But not enough of us. I remember when I learned TDD back in 2010, I saw such strength in this way of developing that I thought one day, and I went on record with this, there's a blog post out there, one day we're going to stop calling this TDD, and we're just going to call it D. This is just how we're going to be doing it. And I was wrong. Ideas tend to be either built to spread or built to last. This one lasted in pockets where it didn't spread, and where it spread, it changed into something it was never meant to be, and it's been widely misunderstood, I think. Because every time the idea goes into somebody's head, they bring their own context, they bring their own whole thing, and usually, this is another lesson I learned in the last couple of weeks on LinkedIn, people don't read past the first line. People don't read past the title to understand what it means. They see test-driven development. Yeah, and for some reason, this idea spread and lost its meaning. And I think I know the reason. I have a hypothesis. Test-driven development was never about testing. If you get it, you know what I'm saying. This talk, when it comes down to it, what I'm trying to say is this is less about methodology than about terminology and vocabulary. And, like our keynote speaker was saying, the way you think about the thing frames the thing. And we're in knowledge work. The way you think about the work is the ball game. And the words frame how we think about the work. So I have a proposal. We're not calling it testing anymore. We remove any mention of tests or test-adjacent terminology from how we talk about this practice. But every objection that I rattled off in that first slide flows from this single mistake that we called this technique test-driven development. A test is something that you can do to something that already exists. Testing is a whole job in our industry, and it has nothing to do with TDD. The idea hits a wall when you try to bring it to reality in an environment where testing means a certain thing. You do end up testing the framework in a lot of these code bases because the logic that you want to test is pureed in with the framework glue code in a way where it's not separable, and that's not visible to most engineers who don't know what they're looking at from a TDD perspective. It's in the writing of the code that we discover the code we need to write. And calling people unprofessional isn't motivating, it's abusive. But like I said, TDD was a strong idea, and it's an important practice. So how should we talk about it? A test, when it comes down to it, a test is essentially an assertion. And if we change that to the language of, I'm going to follow the language of specification here and say that's an expectation. When we write a failing test, we're setting an expectation. So, if you're an annoying nerd coach like me and you see somebody go for the production code first, the classic line is, hey, did you write a test for that? So instead, we could say, did you set an expectation for that? That makes a little more sense. And a test suite, a collection of expectations, is a specification. We had red, green, refactor, the waltz, the cycle. And now we can say, set an expectation, meet an expectation, and design. So refactoring, that's another word that got polluted. Refactoring has become a synonym for I'm improving the software system, I'm adding a feature to it, or I'm fixing a bug, I refactored it to fix that bug. Originally, it was supposed to be just changing the code's form, its design, without changing its behavior. Even performance tuning is changing its behavior. The verb is tuning. You're not refactoring to make it faster. So I want to be really intentional about that third word, enough that I spend a couple of minutes on it. It's not refactoring, it's design. You're designing your code once it meets expectations. And so we got the 3 A's, arrange, act, assert, the 3 parts of a test. We can make them the 3 E's now. Establish, execute, expect. So we're establishing the preconditions and the inputs and the things in which that execution happens, and then we set expectations about the results. In the field of mocks, I won't spend too much time on this because this is a whole talk, and it's also a whole talk that I don't give. But nullables, so it's basically, it's nullable class is production code that you can just kind of switch off when it comes to things like database calls or network calls and have it return a pre-configured response. It's perfect for specification and running within process without side effects. And we have a couple of classes of automated tests, like end-to-end tests, system tests versus unit tests. I think we could simplify this discussion and turn it into user specs and code specs. Who's seen the testing pyramid before? Here's another tragedy in naming. That is a triangle. The point of this visual was always to indicate you should do less of these things and much more of these things. And so we can represent it this is a user spec or a system spec versus code specs, of which we want many, many thousands in a decently sized system. Okay, so again, isn't this just BDD because we're saying specification instead of test? Well, yes, technically, I'm starting from that point, but I really am talking about the methodology formerly known as TDD. And the words are different because, again, words matter. I owe a tremendous debt of intellectual gratitude to the BDD people for planting the phrase executable specification in my vocabulary. But BDD really thrives at the seam between engineers and non-engineers in terms of giving them a precise technical language, the given when then, the Gherkin syntax, like a precise but non-code language in which they could describe specifications for a system, usually from a user's perspective. So that's different from code specs in the guts of the actual design of the code that you're specifying. So that's kind of where BDD falls in relation to this. And of course, the question, isn't this just spec-driven development? No, it's not that either. What stands out to me when I try to understand what people are calling spec-driven development these days is that it's a minefield of misappropriated terms. For example, executable specifications, they're using that to talk about markdown files that you feed into an LLM now. So that's a completely different idea than that phrase meant several years ago when we were talking about BDD. And I get that maybe my whole premise here isn't helping with semantic diffusion. But one thing that sticks out to me about spec-driven development as it's being described, it's an echo of if we figure it all up front once and lock it in, then we could just get the offshore team, the agents, to build it while we sleep, and we're going to make so much money, bro. It sounds good on paper, but it's the same old trap. Spec everything once and then delegate. It's waterfall with a GPU. There's probably people doing wholesome implementations of this where it's not that. But that's what most of the descriptions that I see about this end up sounding like to me. With that story up front, it's going to, I fear it's going to suffer the same fate as test-driven development by having, like this befuddled nomenclature that belies its intended meaning. It undermines what it's actually trying to do by presenting this idea of, let's write the spec. Thinking up front with rigor and clarity, specification, that's good. That's good, but we have to do it in dialogue with making. Engineering is a dialogue, and specification must be continuous. So that's what I want to call this. It's not TDD, it's continuous specification. Like continuous integration, like continuous deployment. And what I like about the continuosity idea means not only early and often, but as early and as often as possible. Like the further you push this, the better the results are going to be. And that was the same as it was with test-driven development. TDD, the name, in quotes, is dead. And with the benefit of a few decades of hindsight, and all due respect to Kent Beck and the gang, this is what we should have called it. It may not make sense to test that code that you're wrestling with right now. But it sure makes sense to step back and specify what you want from it, especially if it's a wrestling match. And once it meets spec, to design it carefully so that the next change you make to it is a little easier, continuously throughout the coding process. Cool. But bro, it's 2026. Coding is a solved problem, remember? The agents write the code now, so why does any of this matter? It's a fair question. If the machine writes it for us, who cares how? You care. You care the moment you have to change it, even if you've got a genie to change it for you. Kent Beck calls this Constantine's equivalence. The cost of software is approximately equal to the cost of changing it. And what you might notice missing from this formula is the cost of writing the software in the first place. That's because the cost of creating the software in the first place, which everybody's paying attention to, is statistically insignificant. So much so that it's approximately not there. So writing the system the first time, when it's greenfield, your manager is like freaking out about how it's taking you a month and a half on that user story that you're working on. But that month and a half doesn't matter. In the grand scheme of the cost of that software system, you're going to be paying for that feature way more than a month and a half that it took to implement it. But we can't measure that. It's indirect, it's woven into the fabric of the system, into the code, and you can't trace those costs. They look like costs of adding a feature later, but you're actually paying for the first features you built and how well you did that. An agent coding without continuous specification is going to give you that whatever, like 10x, 100x fast output you're looking for. It'll be fast, but it will do it exactly the way it learned to from thousands of strangers on GitHub. it will pass its own vibe check every time. Speaking of testing your own code. And you're left with no control over the value of your software. You guys see this one? It's in the doing of the work that we discover the work that we need to do. That's still a problem that the genies have. It's not just a problem that we humans have. If we imagine the process of software engineering to be a linear process, while powering it with coding agents, we're just going to exponentially pollute the world with unusable software that has no value. Continuous specification is a device for processing the information that your code gives back to you as you write it. As you do the work, information flies off it. That's a working definition for knowledge work of any kind, including software engineering. Your code is giving you this information and you have to process it in real time. With continuous specification, you can use that information, what it's telling you, what the resistance it gives you based on the design you have. You can use it to change your code easier into code that's easier to change. And generating code in this tight cycle of specify, implement, and design. We're not working around a human quirk. The cycle produces a different quality of output. And I'm not talking about like a one-dimensional quality, like this is good quality, this is bad quality. I'm talking about things that you experience, aspects of the experience of the code itself, like readability, scannability, resilience in the face of change. And agents they're not us, they're not people, they never will be, but they're good enough imitations of us that how they work matters, not just what they produce. And to the extent to which they think, how they think about the work matters. Give your agent the right frame without the confusion of calling it testing, and you'll still get code fast, but you'll also be able to work with that code again in a month, a year, 5 years from now. And I think you need to give your agents this skill now if you want your software to be worth anything later. Okay, this is a skill that will teach your agent to do continuous specification, and they won't call it testing. Share and enjoy. To beat a phrase to death, when you've been doing this as long as I have, you hear a lot of popular acronym or popular technique is dead. Posts, talks. I just saw MCP is dead the other week. That's exciting. I'm not going to the funeral. I didn't know them too well. But for what it's worth, I'm sorry that I yanked on that handle to get your attention. But I thought this was an important conversation, and thank you for coming. But now I want to hear from you. If we had called this continuous specification or something like expectation-driven development or something, anything but testing, do you think it would be different? What do you think?